Welcome to this explainer. Today, we're diving into a massive, fundamental shift in how we build software. We're looking at exactly how standardized protocols are transforming isolated, messy coding scripts into a powerful, incredibly scalable virtual workforce. Now, whether you're brand new to software development or you've been working with AI for a while, what we're going to cover today is absolutely going to change how you think about building applications. So let's be real for a second and think about your current workflow. Are you stuck writing these fragile, bespoke wrappers for every single new integration? Like when you want your code to talk to a database or an external API, are you manually wiring it all together like some custom machine in a garage? Because today, we're going to explore how open standards allow you to completely stop doing that and instead help you orchestrate a true plug-and-play factory. To get there, we have to look at the core architecture. The basic equation for any AI agent is pretty simple. It equals the model plus the harness. Now, the model is the brain, but the harness? That's how it actually interacts with the world. Without open protocols, every single harness is a custom nightmare. But by adopting standardized layers, you transform that messy code into a clean, modular platform. You literally stop debugging custom data formats and start directing high-level intent. Here is our roadmap for how we'll break this all down. We're covering 1. The monolithic ceiling, 2. The universal socket, 3. Bounded versus unbounded domains, 4. The virtual workforce, and finally, 5. Interfaces and commerce. Let's jump right in. All right, Section 1, the monolithic ceiling. You know the classic Swiss Army knife approach, right? It's where you rely on a single massive prompt, and one agent tries to wear multiple hats, handling the databases, the interfaces, and the testing all at once. Well, that hits a ceiling really fast, because the more tools you give this single agent, the worse its decision-making actually becomes. It gets completely overwhelmed with contextual overload, and a bug in just one tool can bring the whole system crashing down. It is a massive single point of failure. And honestly, the math behind maintaining a system like that is a total nightmare. Say you use 5 different AI models and connect them to 10 different tools. Traditional, manual coding means you are maintaining 50 bespoke connection points. If just one tool changes, everything breaks. But with open protocols, we completely flatten that complexity. You write the connection for a tool exactly once, and it works universally across all your models.
Which brings us nicely to Section 2, MCP, the universal socket.
So, what is this magic fix? It's the Model Context Protocol, or MCP. I like to think of MCP as the USB-C port for your AI agent. It gives you an instant, standardized connection to external databases and APIs without you ever having to write fragile custom code again. It standardizes the tool definitions so your agent can just plug right in and get to work. No more messy JSON parsers. And as a developer, adopting MCP is incredibly straightforward. It's really just a 3-step process. First up is discovery. You grab pre-built MCP servers from public registries or internal gateways. Second is configuration. You set your scope, permissions, and credentials. And third is connection. Your client does a quick handshake to list out the available tools and validate the output. True plug and play. But okay, you definitely have to follow some best practices here. Do audit those public servers before hooking them up to your local system. And this is a big one. Do use the MCP inspector. When your agent makes a mistake, please don't blindly guess and tweak the prompt. Use the inspector to identify the exact issues and directly debug the raw transport pipes. On the flip side, don't hard-code your credentials into prompts, and absolutely do not connect these early development agents straight to live production data. Moving on to Section 3, bounded versus unbounded domains. I absolutely love this analogy. Imagine you're renovating a kitchen. You could go out, buy all the hammers and saws and try to do it all yourself. That's like using standard simple tools. Or you could hire a domain specialist who builds kitchens for a living. And when you hire a specialist, you don't just hand them a blueprint and walk away forever, right? You collaborate. They hit a weird edge case, they ask you a question, and you negotiate a solution together. And this is exactly why treating an AI agent like a simple fire-and-forget tool just totally breaks down. Agents operate in messy, unbounded problem-solving spaces. If you try to force a collaborative agent into a simple tool wrapper, you introduce what we call the go-to problem. It's like reading a great book and suddenly being forced to jump to a random chapter. The flow leaves, the structured context, the agent pauses to ask for clarification, and your orchestrator loses its place entirely. We need something better to handle that collaboration. That brings us to Section 4, A2A, the virtual workforce. Enter the agent-to-agent protocol, or A2A. If MCP is the standard block for connecting simple tools, A2A is the standard building block for connecting minds. Think of it as a universal factory radio. It completely abstracts away the underlying programming languages and frameworks. So whether one agent was built in Python by Google and another in LangChain by Salesforce, A2A acts as a lingua franca, allowing them to effortlessly negotiate, delegate, and brainstorm together. Because of A2A, you're no longer limited to agents sitting on your local machine. An orchestrator can now delegate tasks clear across the internet. Picture a real-world scenario where one agent writes an application's code and then securely uses A2A to hire a completely different, specialized QA agent halfway across the world just to test it for bugs. You don't have to maintain the logic for the testing agent yourself. You just use A2A to securely hire that expert over the network.
So how do you actually find and hire these experts? Through the agent card. This is essentially the standardized CV or resume of the AI world. It clearly defines what an agent can do, its security and compliance rules, and its interaction schemas. These cards live in registries. You could have public marketplaces where you license out your specialists globally, or private enterprise registries to safely share internal AI workers across different corporate departments.
Finally, Section 5, Interfaces and Commerce. Up to this point, we've talked about agents talking to tools and to each other. But we have to bridge the communication gap between these systems and humans. That's the agent-to-user interface, or A2UI. There are two main patterns here. First, instead of humans reading raw JSON data, we use generative UI to instantly render safe, visual display windows. The second pattern uses interactive canvas tools, which allow humans to easily verify data and visually guide the agent's actions right on the screen. It totally transforms the user interaction. Okay, but what happens when your agent actually needs to buy something in the real world? That's where UCP and AP2 come in. The Universal Commerce Protocol connects agents to real-world global supply chains. It's basically like the ultimate food delivery app for modern trading workflows. But obviously, they can't just spend freely. Nobody wants their AI accidentally buying a yacht, right? So they use the Agent Payments Protocol, which acts like a parent's credit card. It applies incredibly strict, secure rules for autonomous agent payments to keep everything perfectly on budget in your daily workflows. Bring all of this together and you get this beautifully scalable ecosystem. Your central agent logic sits in the middle. It uses MCP to instantly plug into local tools. It uses A2A to collaborate with a globally distributed workforce of specialists. It uses A2UI to safely show you, the human, exactly what it's doing. And it uses AP2 and UCP to securely conduct real-world commerce. This whole map right here, this is how developers move beyond simple prototyping and into massive agentic factory environments. Which leaves us with one final, very important question. Are you going to keep wasting your time writing fragile API wrappers that break every single time the wind blows? Or are you ready to embrace these open standards, prepare for the very real future of agentic engineering, and command your own highly scalable virtual workforce? The factory floor is ready for you. It's time to take charge.